Alright everybody, time for a video on parallelograms and rhombus notes. So this is where you'll go if you want to see what the properties are before trying out the examples, which there will be a separate video for. Alright, so let's start. A parallelogram is a quadrilateral with two pairs of parallel sides. So if the shape over here is a parallelogram, we'll know that this side is parallel to this side, and that these two sides will be parallel. That's what makes it a parallelogram. That's really the only requirement for something being a parallelogram. So those sets of sides being parallel. If you want to draw in your own parallelogram, you may want to. There are going to be some special properties that parallelograms have that you may want to be able to mark down, which we're going to talk about right now. So, a few things that are true if a quadrilateral is a parallelogram. One thing is that opposite sides are congruent. So not only are these two sides parallel, but these two sides are also congruent, and these two sides are also congruent, but the two pairs of sides do not necessarily need to equal each other in length. So that's one thing we know. If this is a parallelogram, then we also know that opposite angles are congruent. Opposite angles meaning we have this one here, and that's going to be the same size as this one here. These two will also be the same. If this quadrilateral is a parallelogram, we also know that consecutive angles are supplementary. So, if we were to take any two angles that were next to each other, for example, this one and this one, those two added together they'll equal 180 degrees. We could do that with any two angles that are next to each other in the parallelogram. And finally, if we know that this is a quadrilateral, one last thing that we know, and let me clean up my drawing a little bit. You may want to make a second parallelogram or even a few more if you think that this looks a little cluttered. The last thing that we know is that the diagonals bisect each other. So remember, diagonals are going from one corner to the corner all the way across from it. And in this type of shape, while the diagonals in a parallelogram do not need to be the same length, they will cut each other in half, creating two equal halves for each diagonal. So that's a parallelogram. And what we're going to talk about next, and the last thing we're going to talk about in this video, is a rhombus. And a rhombus is a type of parallelogram. It's a specific type of parallelogram. It is a parallelogram with four congruent sides. So this is still parallel to this. This is still parallel to this. But the added thing that we know this time is that all of these sides are the same length. Now what that means is that if you have a rhombus, it's always a parallelogram, but a parallelogram is only sometimes a rhombus. When is it a rhombus? It's a rhombus when all of the sides are congruent. So a few things for us to know for our rhombus. One of them is that a parallelogram is a rhombus if and only if the diagonals are perpendicular. So in your typical parallelogram, if we draw the diagonals in, you'll see that the angles here forming at the center are not 90 degrees. One of them is a little bit bigger, one of them is a little bit smaller. But in our rhombus up here, if I draw in this line, and if I draw in this line, here you see we have our 90-degree angles. So that's the difference. Another significant difference is that a parallelogram is a rhombus if and only if the diagonals bisect angles. So in this rhombus, this should be the same as this. And frankly, this should also be I kind of drew the line off a little bit, but this should be the same size as this. And then the same will be true over here. In a regular parallelogram, that does not necessarily happen. It could, but it doesn't have to. So that is another thing to consider. That's all I have for you on the properties of parallelograms and rhombus. If you want to see some examples of how these properties come into play, watch the video about that. See you later.